Okay, so first part, express minus 8. So express minus 8 and minus 8 root 3 I in the form r cos theta I sin theta. So what's going to happen here is we're going to express it, so it's going to be minus 8, which is 8 to the left, and then it's going to be minus 8 root 3 down. So what we're going to have is a complex number located in this quadrant here, where its distance down is 8 root 3 and its distance across is 8. We're going to find out the angle x, such that tan x equals 8 root 3 over 8. X therefore is going to be tan inverse 8 root 3 all over 8, and what we're going to get is tan inverse root 3, and tan inverse root 3 is going to be 60 degrees. Okay, so now that we know that this is 60, we know that the complete angle has to be 180 plus 60, which is going to be 240 degrees. Okay, now next part after that has a lot to do with we have to find the modulus r, the length of it. Okay, so r equals the square root of the real, which is minus 8 squared, plus the square root of the real squared plus the imaginary squared, all into the calculator. So there we are there, and when we multiply this out, we're going to get that r equals 16. So this changes into 16 bracket cos 240 plus I sin 240 degrees. Okay, so once we're done with that, what we have next is hence find this number to the power of 3. Well, we can express this in polar form to the power of 3, so it can be 16 bracket cos 240 plus I sin 240 to the power of 3. Power of 3 will mean that you multiply the angle by 3 and then you do 16 to the power of 3. So it's going to be 16 to the power of 3. It's going to be cos 270 or 720 plus I sin 720. 720 is what happens when you multiply 3 by 240. And what we're going to get next is put it all into the calculator, multiply it out in two parts, and what we're going to get is 4096 plus 0i, which is 4096. Okay, so next part after that, what we're going to have next is find 4 complex numbers such that Z4 equals all this here. So Z4 equals part 1. Now it's going to be this form here, except I'm going to add in the 360n for the rotations. Okay, so it's going to be 16 bracket cos 240 plus 360n plus I sin 240 plus 360n. Close it. Now you're going to set 4 when you bring it over to your side, turns it into a fraction power. Now this fraction power affects things in 2 different ways. It affects the r value by putting 16 to the power of a quarter in, and it affects the angle by dividing it by 4. So divide all the angles by 4 and we're going to get cos 60 and then plus 90n. Then it's going to be I sin 60 plus 90n. Now we have to find what 16 to the power of a quarter is. 16 to the power of a quarter is going to be 2. Z equals, so we're going to do Z0. So it's going to be 2 cos 60 plus I sin 60. Z1 equals 2 cos 150 plus I sine 150. We're just constantly replacing in, first of all, n equals 0 for the first one, then n equals 1, which is going to get me 60 plus 90. It's going to go up by 90 every time. Z2 is going to be 2 cos 240 plus I sine 240. Then Z3 is going to be 2 cos 330 plus I sine 330. Now there's the 4 roots there, but then we're also going to have Z4, and Z4 is going to be 2 cos 420 plus I sine 420. We're expecting Z0 and Z4 to be a copy of each other. So then you're going to put them into the calculator. And when you put them into the calculator, what we're going to get is 1 plus root 3i, root 3 plus I, and then minus 1 minus root 3i, and then root 3 minus 1i, and then finally the last one's going to be root 3 minus 1i. That's when you just use your calculator over and over again, okay? Now, here are all our points, and we can see that the Z4 is a copy of Z1. So here are our 4 points here. Now, what's asking us to do next is, when plotted on the Argand diagram, the 4 complex numbers line a curve. Find the equation of this curve. Okay, so this involves doing the circle equation of a circle centered at 0, 0. So, what we have when the equation is centered at 0, 0, what's going to happen next is we're going to have this here, and what happens is it's located here. Now this first one, that's the center of 0, 0, and what we're going to have A is, the first one is going to be 1 plus root 3, so that's 1 across, root 3 up, that's going to be Z0. Z1 is root 3 minus I, so minus root 3 plus I, so that's Z1, because it's minus root 3 which is around here, and then plus I is 1 up, and then Z2, or sorry, Z2 is minus 1 minus root 3I, so minus 1 here, minus root 3I, so that's going to be Z2, and finally this one here is going to be Z3. Now, what we can see here is that they all lie on a circle. Now, the equation of a circle, when it lies on 0, 0, you have to look at its radius. It has a radius of 2. So it's going to be x squared plus y squared equals 2 squared, x squared plus y squared equals 4. Okay? Next part then. Draw this curve and plot the 4 complex numbers on the curve. There the curve is drawn, it's the circle, and all 4 complex numbers are labelled accordingly. Finally, label the 4 complex numbers in cyclic order, Z1, Z2, Z3, Z4, name the shape Z1, Z2, Z3, Z4. So what once we doing this time is, once we changing that to 1, that to 2, that to 3, and that to 4. This shape is technically, we draw a line, is going to be a square, because it's linked them all together and it's going to be in a square format. Okay, so it's going to be a square. Okay.